We're at Tokamak Energy in Oxfordshire, and this is the ST25. Now, we can operate this machine from anywhere around the world, but there are still things that need to be done here to get us ready. Our technical director, Alan Sykes, is going to talk us through what needs to be done to get this machine ready for operations.
The first thing we do before we start operations is to fill the cold trap. This is a bucket full of liquid nitrogen, and the idea is that the hydrogen that starts off in this plenum here is supposed to be 99.99% pure, but quite often you get a very small amount of moisture inside it. So it goes through this cold trap and just freezes out. Today, going through that cold trap, we should have perfectly pure hydrogen, and it then goes through the pipework and gets injected into the tokamak. The next stage is to open this small valve here, which allows the gas to get inside the plasma vessel. We tend to close this every night and then open it in the morning just in case there's some leakage in the system, because you don't want to fill the vessel with air during the night, or it ruins the condition because a lot of water gets in. And the next thing to do is everything is now safe up here, but these capacitor banks during operations get charged to quite high voltages, sometimes several thousand volts, and that's the main reason why we're in a cage and people are kept out while we operate the machine. The capacitors store up energy. To make the plasma, we need hundreds of thousands of amperes current, and it's very expensive to get that from the national grid. But if you charge these supercapacitors for about 5 or 10 minutes at a rate of about 10 amps, they store an enormous amount of energy, and released in a few seconds, that will give you the 100 kiloamps of current you need in the coils. Everything's ready for operations now, and all I have to do is turn on the chargers, which will let the banks charge up when I tell them to from the control system. So we can now lock the area up, and to do that we have a full safety system, and that lets me take this key out of here, and I can put that key in there, and that lets you get this key, and then we go over to here, and now the system is switched on. And the next stage to do is to raise the dumps and the earths, because when the machine was closed down, first of all a pneumatic dump switch was closed, and after that time the hard earth comes down, another pneumatic system, and then when you go away there's no charge left on the banks at all. So now we've come along the next day, and we have to reverse this process, and we have to raise these dumps so they're not connected to earth anymore. So you can hear the noise as they're raised. So the microwave units are in here, and first of all I turn on the cooling water pumps. Here those start, and then I activate these. And these are glorified domestic microwave units, except they're 3 kilowatts rather than 1 kilowatt. And the steady state, they'll run all day, and they can run in various modes that is useful for us. But it's the same frequency as a domestic microwave. And I have to do some controls on here, and now it's ready for running. So this will deliver 3 kilowatts of microwaves when it's controlled by the control system. And the microwave is a very good way of ionizing the plasma and forming plasma currents, and it's a recognized way of current drive in plasmas, along with neutral beam injection. This is our main control screen. We can control the voltage on the capacitor banks. This one controls the main toroidal field coils. When they're energized, they pass a current of about 100,000 amps down the center column, and it gives a strong toroidal field, which is the essential element of a tokamak. There are subsidiary systems as well, which give fields that control the plasma. Over here we have our control for the gas valve, the pizza valve, which tells you how many pulses there's going to be, and how long between the pulses and how wide the pulses are. So you can give it a lot of gas or a small amount of gas. And down here is the control of the RF microwave unit, like your domestic microwave, which breaks down the plasma and drives a plasma current. And after the hooter, we should see a plasma. There we are.